Okay, we're ready now for problem 9. In problem 9, you start working with composite functions. So let me just write out the problem, then we'll take a few minutes and talk about how we go about solving composite functions. So it says given f of x equals 3x squared minus 2, and then they give you a second function, g of x, 7 minus 1/2 x squared. And then 4 parts they want you to solve. So let's just look at part A. This empty circle here means composite. So I just simply say f composite g of 4. Now here's the thing about composite functions. They're really not very hard, but the whole key is every time I ever work a problem with composite functions, the first thing I do is always rewrite it and I turn it into what I'll call a pure function problem. And by that I mean f composite g of 4, I always rewrite it, and you take your first function first, f of, and then whatever function the second goes inside, and in this case then, so f composite g of 4 means f of g of 4. Now just for learning's sake, before I do this problem, let me actually work out a problem like this, which I think we might do in the next problem, but just to sort of make sure you understand the principle. Say they had asked for f composite g of x. Once again, I always rewrite that as just functions f of g of x. I do it this way because I want to go ahead and just explain, make sure everybody understands what we're doing here. F of g of x says, I think most of you understand function notation, where just for fun, if I said, what is f of 2? Function notation means you get your f function, right? F of x equals 3x squared minus 2. F of 2 says, hey, every place you have an x in this function, you replace it with the number 2. So my function 3x squared, but I don't write x, I replace x with a 2. So it becomes 3 times 2 squared, because the 2 is replacing my x. So 3x squared minus 2, and this should be f of 2. 3 times 4, which is 12, it's like 10. Just to make the point clear, what would happen if I was asked to find f of a? Well, what does that mean? You go to your f function, and now every place you have an x in your function, you replace it with the letter a. So f of x is 3x squared minus 2. F of a would be 3, but instead of x, I replace it with the a, 3a squared minus 2. All right, with that brief review of how we handle functions, let's go back and look at our problem now. Up here, I said this composite function can be rewritten as f of g of 4. Now in this case, just so you guys understand it. Say they had given us the problem f composite g of x. For this one, you take your f function, and every place you have an x, you replace it with g of x. So my f function is 3x squared minus 2. So I put the 3. Now for x squared, I replace the x with the whole second function. 7 minus. So this whole thing is my g of x. And of course I have to square it, because it's actually 3x squared. 3x squared, then minus 2. Now I'm not actually going to finish this. If this was actually a signed problem, you'd have to multiply out these parentheses. These parentheses are squared. You have to FOIL it and then combine like terms, and it's sort of messy. So that, let me write it here. Just to make it very clear. What I've done here is f composite g of x, which I rewrote as f of g of x, ends up being this. The nice thing is, finally, the actual first problem they've given us, f of g of 4, when they do g of 4 instead of g of x, it actually makes it an easier problem. Because what I'm going to do is, I'm going to go ahead and I'm going to first figure out what g of 4 equals. So I'm going to go over here and say, well, what is g of 4? G of 4 means you take the g function and you replace x with 4. I look at the top here. There's my g function, 7 minus 1/2 x squared. So g of 4 means I simply put a 4 in for x. So I would have g of 4 equals 7 minus 1/2 4 squared. 4 squared is 16. 16 over 2 is 8. I think I end up with minus 1. So g of 4 equals minus 1. So therefore I can say, back at the beginning, f composite g of 4, which I rewrite as all functions, f of g of 4, but since I've determined g of 4 is negative 1, you know what I really have? F of negative 1. So now I go to my f function. Every place I have an x, I replace it with minus 1. So 3x squared becomes 3 minus 1 squared, and minus 2. This is 1. 3 times 1 is 3. Looks like this whole thing equals 1. All right. So this is the long way to try to explain what we're doing now. I'm going to do the rest of the 3 problems just straight through. So hopefully this sort of gives a quick review of functions and composites. But now, if I do the rest of the problems, of course I'm not going to do all that work. I'll just pretty much get straight to finding the solution. So for part B, they ask for G composite F of 2. Once again, first thing you always do, at least I do it, I rewrite this as just functions. So this can be written as G of F of 2. just because I understand function and function notation, and this composite function is a little bit new. So just to be safe, why not just write it out as function notation? So I'm going to go figure out what f of 2 equals. Once again, in the problem we're working, I guess I could put them here. F of x was 3x squared minus 2. And g of x was 7 minus 1/2 x squared. So f of 2, you put a 2 in for x in the f function. So it'll be 3 times 2 squared minus 2. 4 times 3 is 12. 12 minus 2 is 10. Looks like f of 2 equals 10. So now I can say g of f of 2 is really g of 10. So I go to my g function and I plug in 10 for x. 7 minus 1/2 10 squared. And you follow order operations to do the math correctly. You have 100 over 2, which is 50. There's the answer for part B. Part C, it's interesting. Let's see how you go about this. F, composite F, of 1. Maybe at first you're confused about what to do here, but if you just simply rewrite it in function notation, f of 1. So first thing is, let's go figure out f of 1. So f of 1 means you go to the f function. Every place you have an x, you put a 1 in there. So it'll be 3 times 1 squared minus 2. So it's going to be 1. So f of 1 really becomes just f of 1. And f of 1, you take the f function, put a 1 in for x, which we actually just did. So it looks like f composite f of 1 equals 1. And then the last problem, problem D, similar g of g of 0. First step, composite functions, always change this to g of 0. Let's go figure out what g of 0 is. Here's my g equation. I plug a 0 in for x. Even though you can't see the equation. 7 minus 1/2 0 squared, which is going to be 7. So now I end up with g of 0, which means g of 7. So you take your g function and you put a 7 in for x. 7 minus 1/2 7 squared. Let me just try to finish out this math. 7 minus 49 over 2. If I'm going to combine these, if I put my first number 7 as a fraction over 2, be 14 over 2 minus 49 over 2. If I didn't mess up, that's a pretty ugly number, but I hope it's correct. And I do have the answers here, and it turns out it is correct. All right, so that's the first problem on the review on composite functions. Let's do another one. So this will be problem 10. It's also a composite function problem. Once again, they give you two functions. Let's say f of x equals 6x plus 4. And g of x equals 7x. And once again, they ask you for 4 parts. Part A, f composite g of x. So unlike the problem we just did, now we're going to have to go ahead and just, our answers are going to probably have an x in them. We're not sticking in a number for x. We're just going to leave it as x and do the algebra. So first thing you do is rewrite this as a function. Start again. F of g of x. So you go to your f function, 6x plus 4. Every place you have an x, you place it with the function g. 6x plus 4 instead of x, I'm going to plug in g of x, which is 7x. So 6x plus 4, 42x plus 6. And I look, thankfully I have the answers here, and it looks like I made a math error. So that happens. Let me just see, maybe you're watching and you saw me make it, and you're trying to scream at me. So f composite g of x is f of g of x. The f function, 6x, so you put in here 6 times 7x plus 4, 42x. Now I'm just looking for a minute to see if I am missing something. Oh, you know what it is? Wow, what a mistake. I had 4 here and I wrote 6. Whoops. Sorry about that. So actually I did the math correctly. But this is a two-part question, because then they ask for the domain of the composite function. And once again, let's write this as a function, because what really happens is you figure out the domain of the inside function. And we've talked about domain on the last test. I'm not going to take the time to discuss how to find the domain. So you take the domain of g of x, and then in a sense you combine it or intersect it with, so first you look at domain of g of x, and then You look at the domain of your final answer, and then you compare what those two have in common. So in this case, if I look at the domain of g of x, once again, you remember about domains, the only thing I have to worry about is if I have variables under the denominator or variables under the square root. Other than that, it's all real numbers. So the domain of g of x is all real. And then I look at my answer. My answer was 42x plus 4. The domain of my answer is all real. So when I take the intersection of these, obviously, it's all real. So you have to take the domain of the inside function and then the domain of your answer, and you intersect those together. Okay, let's do the rest of these problems. B says G composite F of x. Once again, let's write it in function notation, G of F of x. So you take your G function, every place you have an x, replace it with the F function. So the G function is 7x. For that x, I'm going to stick in 6x plus 4 in for x. So I have 7 multiply out parentheses. Looks like for part B, the composite function is 42x plus 28. And if I look at the domain, once again, here's my inside function. That domain is all real. My answer is all real. The domain is still all real. See if we can get through these last couple quickly. C is F composite F. So once again, F of x. So you take your F function, every place you have an x, you replace it with the F function again. So 6 times x, but instead of x, I put in the F function, 6x plus 4. 6x plus 4, right? Because this is my F function, and I had to plug it in again. So if I do the math, 36x plus 24 plus 4, 36x plus 28. If I look at the domain of the inside function, it's real, all real, and outside all real. For C, the domain is all real. And finally for D, they want me to do G composite G of x, which I always rewrite as a function G of x. Take the G function, every place you have an x, you replace it with the G function again. So 7 times x, but instead of x, I put in the G function, which is 7x. Looks like G composite G of x is 49x, and once again, the domain is all real. All right, so composite functions. Not that difficult. I think the whole key is rewriting the composite function as what I call a pure function. All right, we'll stop here and keep going in a minute.